Hello everyone, welcome back to Bimo Pabilchan. This video, we are going to learn about partial fraction decomposition. So what is partial fraction decomposition? Partial fraction decomposition is a process to split or decompose a single algebraic fraction into two or more partial fraction. So before we learn what is partial fraction and what is the process to decompose a single fraction, let's learn about two types of algebraic fraction. So let's say I have algebraic fraction in the form of px over qx. So px is the numerator while qx is the denominator. So we have two types based on the degree or the highest power of x for px and also qx. So the first one is proper algebraic fraction, where the degree of px, the numerator, less than the degree of denominator or qx. So let's take a look at example. So the first example, we have 1 over 2x plus 1. This is proper because the numerator degree is 0, which is x0, while the degree of the denominator is 1. The highest power of x in the denominator is 1. So this is proper. The second example, it's obvious that the numerator degree is 5 less than denominator degree, which is 7. For the third example, as you can see here, the numerator degree is 1 while the denominator degree is 2 because you have x times x, you get x squared. So the degree is 2. So whenever you have numerator degree is less than denominator degree, means that it is proper. How about the second type? The second type, or we call it as improper, is the opposite. While the degree of the numerator or px is greater than or equals to qx or denominator. So whenever they have equal degree, for example 1 and 2 here. So for the first one, the degree for numerator and denominator 2, they are same, means that it is improper. The second example also same. Numerator degree is 1, while the denominator also 1. And when we say improper, it means that we can still simplify it further. So we can divide this with this using long division, and you can still get remainder. So that's what it means by improper. While proper, you cannot divide anymore. For the third one, as you can see, the numerator degree is bigger than the denominator, 3 and 2. While this one also, the numerator degree is 3, while denominator degree is 2 because you multiply x with x, you get x squared. Now, let's take a look at how do we do partial fraction, change it into single fraction. We already learned this in algebra class before. So if you have two separated fraction, we call it as partial fraction, and we can combine it into a single fraction. So let's say I have 5 over x plus 3 plus 4 over x minus 2. As you can see here, we have two proper fraction, and if we combine them, so we can combine them, we multiply the denominator, become x plus 3 times x minus 2, and then we have this divided by this, you get x minus 2, and then times 5, you get 5 times x minus 2 plus 4 times x plus 3. Now you can simplify it, becomes 5x minus 10 plus 4x plus 12 divided by x plus 3 times x minus 2. And then you get 9x plus 2 over x plus 3, x minus 2. So this is the process from partial fraction into single algebraic fraction. Yeah, let's take a look at the second example here. So we have the same denominator, but for this one, we have square. So instead of multiplying them, we can just use x plus 1 square instead, because we can divide x plus 1 square divided by x plus 1, you get x plus 1, and then times 3 here, and then you get 3 times x plus 1. While the second one is just 2, yeah, because we take the denominator here, and then we just simplify it, becomes 3x plus 3 plus 2, and then we have divided by x plus 1 squared. So we get 3x plus 5 over x plus 1 squared. The third example also same, but now we can combine denominator with different degree, but the same process, same step, x minus 1 times x plus x squared plus 5, and then this one I got 2 times x squared plus 5 plus 3x minus 1 times x minus 1. And you can simplify it further. I got 2x squared plus 10 plus I got 3x squared minus 3x minus x, you got minus 4x, and then minus 1 times minus 1, you get plus 1. Now you can simplify it further. I got 5x squared minus 4x plus 11 divided by x minus 1 times x squared plus 5. Now, in this video, we are going to focus on doing the reverse. So, from this form, how do I convert it into its partial fraction? From this form, how do I convert it into partial fraction? From this form, how do I convert it into its partial fraction? So this is called partial fraction decomposition. We are going to do the reverse. So let's take a look at the first example. The first example, express 2x minus 13 divided by 2x plus 1 over x minus 3. So in partial fraction. So what we can do here, I want to split 2x minus 13 divided by 2x plus 1 times x minus 3 into its partial fraction. I have 2x plus 1 plus I have x minus 3. But the problem is we don't know the numerator part, right? But we know for sure that if you look at the first example here, I can just split x plus 3, x minus 2 into its separated fraction denominator. But the top part, we don't know this value. But if you pay attention, this is proper. And if you decompose that, you will get another separated proper fraction. So in order for this two to be proper, means that the degree of numerator has to be less than denominator. As you can see, this is the numerator degree is 1. That means the numerator degree is less than 1, which is a constant. So that means we have two unknown, the constant. Let's say we have A and B. Yeah, once again, this is proper fraction. When you decompose proper fraction, you will get separated proper fraction, partial fractions. And because the denominator degree is 1, that means the numerator has to be less than that. That means it's only a constant. So, how do we find A and B? You can just combine it again. So, when you combine it, you will get 2x plus 1 times x minus 3. Yeah, and then we have A times x minus 3 plus B times 2x plus 1. Now, after we combine these two, we compare. So we compare the numerator in the question with the numerator that we have here. So there should be equal. So we have 2x minus 13 equals to, you can expand, becomes ax minus 3a. And then we have plus 2bx plus b. Now, how do we compare these two? Well, you can factorize the x. So for this one, let's gather the one that has x. So we have x times a and then plus 2b. And then we have the constant, which is minus 3a plus b. Why we collect them? Because we can compare. So the x term with the x term, there should be equal. So a plus 2b equals to 2. And the second one, the constant, we have this and this. They should be equal. So minus 3a plus b equals to minus 13. So from here, we can do the elimination. Yeah, so let's multiply this by 2. So you get minus 6a plus 2b equals to minus 26. And we subtract with this. A plus 2b equals to 2. So we subtract. So we cross out 2b. Now we get minus 7a equals to minus 28. That means a equals to 4. After you get a equals to 4, just plug into one of the equation that we have to get b. So 4 plus 2b equals to 2. So you get 2b equals to minus 2, b equals to minus 1. Now we have a and b. So the final result will be just plug in a, which is 4 over 2x plus 1. And the b is minus 1, so minus 1 over x minus 3. So this is the final answer. We successfully decompose the fraction. Move on to the next question. Here we have from past paper, yeah. 24x plus 13 over 1 minus 2x times 2 plus x squared. So the difference here is I have linear being squared. So it's a little bit different. So let's see how is it different. 24x plus 13 divided by 1 minus 2x times 2 plus x squared. So when we decompose this, I will get the first term, obviously, 1 minus 2x, yeah. And the second one, we have 2 plus x squared, but we have the third one, which is 1 plus 2x, sorry, 2 plus x without square. Why? Because if you look at my second example, the fraction x plus 1 square, you can decompose that into x plus 1 and x plus 1 square. And we have the constant on top. So as you can see, we can have x plus 1 square and we have x plus 1. So for this one, we have 3 partial fraction. And we have 3 unknowns, a, b, and c. Keep in mind that even though we have denominator 2 here, doesn't mean that we have numerator degree 1 here, because this has to be decomposed into this one as well. So all of them has to be constant. And we combine them once again. So we have 1 minus 2x times 2 plus x squared. And then we have a times 2 plus x squared plus b times 1 minus 2x plus c times, this one will be 1 minus 2x, 2 plus x. Yeah, and we once again, we compare this and all of this. It's going to be long, guys. So we have 24x plus 13 equals to, we expand this, we get 4a plus 4ax plus ax squared plus b minus 2bx plus c. And we can expand these two first. We get 2, and then we have x minus 4x, we get minus 3x minus 2x squared. And then we can simplify first. This one same. And then we can expand the c. You will get plus 2c minus 3cx minus 2cx squared. Now, once again, we can collect the x. But now we have x squared. So let's collect x squared first. So x squared, we have a. And we also have minus 2c. And we collect x. We have 4a minus 2b minus 3c. And the constant we have for a plus b plus b plus 2c. Now, let's compare. The right side we have x squared, but the left side we don't have x squared. So that means it should be 0. So a minus 2c equals to 0. And the second one, we have 24x. The 24 equals to the x on the right side. We have for a minus 2b minus 3c. And the constant we have 13 equals to 4a plus b plus 2c. Now, we can just do algebra here. From here, we get a equals to 2c. And then we can plug in a to the second and third equation. So from the second equation, we get 24 equals to 8c minus 2b minus 3c. So I got 24 equals to 5c minus 2b. This is 13 equals to 8c plus b plus 2c. So I got 13 equals to 10c plus b. Now, as you can see, we have two equations with b and c. We can do elimination. So I got this one. Maybe I can multiply by 2. Or maybe this one. Same thing, yeah. I can multiply this by 2. So I got 48 equals to 10c minus 4b. So and then I subtract with this. 13 equals to 10c plus b. So I subtract. This one cancel. This one I got minus 5b. This one I got 35. So b equals to minus 7. B equals to minus 7. You can find a and c. So from this equation, 13 equals to 10c minus 7. So 10c equals to 20, c equals to 2. And because a equals to 2c, we get a equals to 4. So I got the unknowns. So that means I can just plug into my partial fraction. So a over 1 minus 2x. So the partial fraction will be 4 over 1 minus 2x. And then the b is minus 7. So minus 7 over 2 plus x squared. And then we have plus 2 over 2 plus x. So we have the answer here. Move on to the third question. We have a partial fraction again, but this one is different because as you can see here, we have quadratic. And if you look at the quadratic, it cannot be factorized. So we cannot factorize it into two separated linear factor. So this one a little bit different. So let's see how we do it. So let's do partial fraction. So when we decompose, we get 2 plus 3x squared plus 2 minus x. Now, as you can see here, this one, the degree is 2. That means the numerator degree has to be less than that. So we have two options, either degree 0 or degree 1. But we can assume that it's degree 1, ax plus b, linear, because if it is degree 0, the a value is 0. So we have to take the worst scenario, which is the linear part. So the degree has to be less than 1, less than the degree of the denominator. While the second one, it's only constant, so it's c, sorry. So now we can combine once again. So I have 2 plus 3x squared times 2 minus x, and we can combine them. Ax plus b times 2 minus x plus c times 2 plus 3x squared. So once again, if you have irreducible quadratic in the denominator, the top part has to be linear, 1 degree less than that, which is ax plus b. So now we can combine. So we can, once again, we can compare. So I have 17x squared minus 7x plus 16 equals to, this one we can expand. Yeah. So I have 2ax minus ax squared plus 2b minus bx plus 2c plus 3cx squared divided, oh, we just focus on the numerator. So yeah. And we can once again collect the x square. So x square in the bracket, we have minus a. We also have plus 3c. And we can collect the x. We have 2a. We have minus b. And we have the constant, which is 2b plus 2c. Now, from here we can compare the first one, the x square coefficient. We have minus a plus 3c equals to 17. The x coefficient, we have 2a minus b equals to minus 7. And the third one is 2b plus 2c equals to 16. I can simplify this into b plus c equals to 8. Now, what we can do here, we can just do substitution and elimination. This one I have b equals to 8 minus c. I can plug into this. So I have 2a minus b is 8 minus c equals to minus 7. So I have 2a minus 8 plus 7 equals to minus 7, or 2a plus c equals to 1. And then I have minus a plus 3c equals 17. So I can multiply by 2 to eliminate 2a, minus 2a plus 6c equals to 34. So I can add them instead to cross out the 2a. So I have 7c equals to 35, or c equals to 5. When c equals to 5, b equals to 3. And when b equals to 3, a equals to, let's plug into this. So 2a minus 3 equals to minus 7. 2a equals to minus 4. So a equals to minus 2. So now we have a, b, and c. So just plug into our partial fraction. So the final answer will be ax plus b. So minus 2, sorry, minus 2 x plus b plus 3 divided by 2 plus 3x squared plus c is 5 over 2 minus x. So this is our final answer. Okay guys, let's move on to the last question. In the last question here, if you pay attention to the question, this is improper. So how do we decompose improper? First, you need to simplify it into proper fraction. So this one, if we expand this, you will get 2x squared and then plus x minus 2x become minus x minus 1. And then we do the long division. So we get 6x squared minus 2x plus 2 divided by 2x squared minus x minus 1. So when we divide this, we get 3. So and then 6x squared minus 3x minus 3. When we subtract, we get x and then plus 5. Now, we can rewrite 6x squared minus 2x plus 2 divided by x minus 1 times 2x plus 1 equals to, the result is 3, yeah, plus the remainder is x plus 5 divided by 2x squared minus x minus 1, the divisor, which is x minus 1 to x plus 1. Nah, so if you whenever you have improper fraction, you can divide first to get proper fraction, and then you can just do the partial fraction. So this one we get A and B. Yeah. Now we can combine again. So we get A times 2x plus 1 plus B times x minus 1. X minus 1 to x plus 1. Now, once again, we compare x plus 5 with this. Yeah, so we get x plus 5 equals to A times 2x plus 1 plus B times x minus 1. We can expand, so we get 2ax plus A plus bx minus b. And then once again, we collect the x, so we get x in the bracket 2a and plus b plus a minus b as a constant. So we have 2a plus b equals to 1, a minus b equals to 5. Now, we can just need to do the elimination. A minus b equals to 5. So I can add. I get 3a equals to 6. A equals to 2. So from a equals to 2 here. So minus b equals to 3 or b equals to minus 3. So we get a and b. So the final answer will be 3 plus 2 over x minus 1 minus 3 over 2x plus 1. So this is the final answer. So thank you for watching this video. I hope you learned something new about partial fraction and see you in the next video. Thank you.